System of linear equation. Ignore at your own risk. JEE loves this topic and so should you. It's a 99.99% exam worthy topic. Okay, so let's start it. Okay, so basically in system of linear equation we are going to see the Cramer's rule. So we'll say Cramer's rule. So according to Cramer's rule, what can we say? Suppose we have three equations and three variables, then how do we solve it? First we'll write the D. What will be D? D will be nothing but simply the coefficient determinant. How coefficient determinant? The first column will be coefficient of x, so a1, a2, a3. Second column coefficient of y, b1, b2, b3, and the third column coefficient of z, that is c1, c2, c3. We have to check out what is the D. Okay, then we write d1 or dx. d1 or dx just basically mean that the first column in the D, we are just replacing with the d1, d2, d3. So first column will be d1, d2, d3, remaining two will be same, that we call d1 or dx. Okay, d2 or dy, what do we mean? That the y coefficient column we are replacing with d1, d2, d3, remaining two will be same. d3 or dz, what do we mean? That the third column we are replacing by d1, d2, d3, and the remaining two will be same. Then by Cramer's rule, what can we say? That x will be dx by d, y will be dy by d, and z will be dz by d. By Cramer's rule, we have seen that x equal to dx by d, y equal to dy by d, and z equal to dz by d. But always it's not possible that we'll have the unique solution only. So can I say now we will discuss on number of solution. Okay, I'll say that everything depends on the d. This d has two choices. Either d can be 0 or d is not equal to 0. If my d is non-equal to 0, then we say that we have the unique solution. And how to find that unique solution? That unique solution will be x equal to dx by d, y equal to dy by d, and z equal to dz by d. Okay, now suppose if my d is 0. So if d is 0, then what we will do? We will further check out dx, dy, and dz. So what we will do? Suppose at the very beginning I will check d. If my d is non-zero, I will go for unique solution. If my d is 0, then what we will do? We will check out dx. If my dx is non-zero, then we will say that no solution. But suppose if dx is 0, then what we will do? Go to dy. Now if dy is not equal to 0, we will say no solution, and if dy is also 0, we will check out dz. If dz not 0, we will stop there only and we will say no solution, or else we will say infinitely many solution or no solution. It means what we are saying, first we will check out d. D non-zero, unique solution. D 0, further we will check dx, dy, dz. So I will go for dx. Dx non-zero, stop there only, no solution. Dx 0, move further, check dy. Dy non-zero, stop there only, no solution. Dy also 0, go and check dz. Dz non-zero, stop there only, no solution. Dz also 0, then we will say here dx, dy, dz all are 0, so we will say infinitely many solution or no solution. Okay. Now, whenever the solution will exist, we say that my system is consistent system, and whenever solution is not there, we say inconsistent. So, in the case of unique solution, system will be consistent system, no solution inconsistent system, and when all the dx, dy, dz are equal, then we will say may or may not be consistent. Okay, in this case, like how can we say may or may not be consistent? Okay, can I say, suppose I have one example that x plus y plus z equal to 1, 2x plus 2y plus 2z equal to 2, and 3x plus 3y plus 3z equal to 5. Now can I say here that d will be 0 since columns are identical? Okay, can I say dx will be 0 since columns are identical? Like that dy, dz, everything will be 0. But can I say here we don't have any solution, no solution. So this is no solution case, but this is very rarely we'll get. Okay, thank you.